Now let's see this partial order. A partial order is a relation if it happens to be three types like this. If it is reflexive, antisymmetric and transitive. If it happens to be reflexive, antisymmetric and transitive, it is going to be partial order. Just like equivalence relation, which has to be reflexive, symmetric and transitive. This one has to be reflexive, antisymmetric and transitive. Generally most people get confused here between the equivalence relations and partial orders. So partial ordering relation is reflexive, antisymmetric and transitive, okay, and equivalence relation is reflexive, symmetric and transitive. So just remember the difference between these two, okay. And we know what is reflexive, the diagonal elements a comma a, b comma b, like that. And what about antisymmetric? You cannot allow symmetric pairs like ab, ba, but you can allow the pairs which are diagonal. Got it? So a relation, okay, just think about it. Can it be possible that a relation can be reflexive, asymmetric and transitive? It is not possible. The reason is, if it is reflexive, it cannot be asymmetric. Therefore, don't get confused here. People generally get confused here. So whenever I say partial order, they say reflexive and transitive is for sure, but then this one they get confused. Sometimes they think that it is symmetric, sometimes they think that it is antisymmetric, sometimes asymmetric, okay. So symmetric is for equivalence and antisymmetric is for partial order. It cannot be asymmetric. The reason is, once it happens to be reflexive, it cannot be asymmetric, because asymmetric will not allow diagonal pairs, remember, and our reflexive allows or wants diagonal pairs. Therefore, it has to be reflexive, antisymmetric and transitive. So for example, you can take this example. Let's say A is a relation like this. A is a set, and if you define a relation R1, which is going to contain 1 1, 2 2, 3 3, right? So what can you say about this relation? This is definitely reflexive, isn't it? And this is definitely transitive. So why am I saying that it is transitive? Because it does not contain a comma b and b comma c. So if it contains a comma b and b comma c, then only there is a chance that it might fail to be transitive. If it does not contain, then definitely it is transitive. And it is definitely symmetric. Why is it symmetric? Because it does not contain any element of type a comma b. If you have a comma b, then only it fails to be symmetric if it does not contain b comma a. Since it does not contain a comma b at all, it contains only a comma a, so it is symmetric. And definitely it is antisymmetric. So antisymmetric also, because it does not contain symmetric pairs and it contains only diagonal elements, and diagonal elements are allowed in antisymmetric. So since it is reflexive, transitive and symmetric, I can call this one as equivalence relation. So R1 is definitely equivalence relation. And since it is reflexive and transitive and antisymmetric, because of these three properties, reflexive, transitive and antisymmetric, I can say that it is partial ordering relation. Therefore, this relation R1, which is containing only the diagonal elements, is actually an example of a relation which is both partial ordering as well as equivalence. In fact, this is the only relation which is both partial ordering and equivalence. And if you try to add anything into this, any element, let us say 1 comma 2, if you try to add 1 comma 2, then it fails to be either symmetric or it fails to be either antisymmetric, right? Therefore, it cannot be both of them. So if you try to add anything into this, then it will be only either equivalence or partial or not. Got it? Therefore, only relation which is both equivalent and partial ordering is this one. And one more interesting point is, this is the smallest relation which is equivalent, and this is the smallest relation which is partial ordering relation. This is the smallest one, and in fact this is the only relation which is in the intersection of these two. And if you try to delete anything from this, for example, if you have these three elements and if this is set, on which you are defining these relations. If you try to delete even one of them, then it fails to be reflexive, and so it will fail to be either equivalence or partial ordering relation. Therefore, this is an important example. Okay, and tell me about this. Let us say, so you must have understood this. Either if a relation has to be either equivalence relation or partial ordering relation, first thing is it should first contain all the diagonal elements, then only we can talk about it. If it does not contain all the diagonal elements, then it fails to be reflexive and we can bluntly reject it there itself, right? So in case, so let's see this. Now when I am testing for this, if it contains only 1 1 and 2 2, right, it cannot be equivalence, it cannot be partial ordering. The reason is it cannot be, it is not reflexive. If we are talking about the set A equal to 1 2 3, and if it contains only these two diagonal elements, it failed to be reflexive, and so it cannot be equivalence or partial ordering. Let us say R3 1 1 2 2 3 3, right, and along with that if you add one more 1 comma 2, what happens now? Now see this, I have added an element. So now will it be symmetric? It will not be symmetric because you have to add 2 comma 1 also. So since the symmetric pair is missing, it cannot be symmetric, therefore it cannot be equivalence relation. What about partial ordering relation? Is it antisymmetric? Yes, it is antisymmetric. And is it transitive? You have to check for transitivity, right? So 1 comma 2 and then 1 comma 2 is here, therefore you should have 1 comma 2, yes, isn't it? 1 comma 1 is there and then 1 comma 2 is there, so you should have 1 comma 2, yes, 1 comma 2 is there, and similarly 1 comma 2 is there and 2 comma 2 is there, therefore you should have 1 comma 2, yes, we have 1 comma 2, therefore it is transitive. So what can you say about it? It is reflexive because it is containing all the elements, and it is antisymmetric because it is not containing any transitive pairs other than these diagonal elements, and it is transitive. So what can you say about it? It is partial ordering relation. Got it? Okay, so now you have seen these examples. There is one more terminology here, so it is interesting because we use it a lot, so it is important as well. Just see this one. A set capital A with a partial order capital R defined on the set capital A is called partially ordered set, and it is denoted by A comma R. I'll tell you the meaning of this. Now if you have a set, let us say any set like here A, any set like that, and if you define a partial order on that, let us say capital R is a set of all real numbers, and we are defining a relation less than or equal to on that. So what is less than or equal to? It is going to be reflexive because A is less than or equal to A, therefore it is definitely reflexive, right? And it is antisymmetric. Why is it antisymmetric? Because if A is less than or equal to B, then B cannot be less than or equal to A. Only case in which it will be satisfied is when A equal to B. Therefore it is antisymmetric. We have already seen it earlier, right? And then it is transitive as well. Why is it transitive? If A is less than or equal to B and B is less than or equal to C, then A will be less than or equal to C. If A is less than or equal to B and B is less than or equal to C, then definitely A is less than or equal to C, which means if A comma B belongs to R and B comma C belongs to R, then definitely A comma C will also belong to R. Therefore this particular relation less than or equal to on the set of real numbers capital R is reflexive, antisymmetric as well as transitive. So what can we say about this relation? It is clear that we can say that it is partially ordering relation. Partial ordering relation on this set. Now when we combine these two, what are these? The R, the set of all real numbers, along with the relation, and if I write like this, this is the set and this is the relation. If I write them like that, it is called as Poset or partially ordered set. It is also called as Poset or partially ordered set. Just remember the terminology. So whenever they write like this, it means that it is a poset or partially ordered set, which means this relation is partially ordered relation on this set capital R. If you want to see one more example, even greater than or equal to is also same, isn't it? On a set of real numbers, if you have greater than or equal to, it is going to be poset. And similarly, let us say capital S is set of all sets. Okay, on this, if you define the relation subset or proper inclusion, if you define this, then it is also a poset. The reason is, capital A, if you have a set capital A is definitely a subset of itself, therefore it is reflexive, and then it is antisymmetric, because if A is subset of B, then B cannot be subset of A unless A equal to B, therefore it is antisymmetric. And then it is transitive as well. The reason is, if A is subset of B and if B is subset of C, which means if A comma B and B comma C belongs to the relation subset, then A comma C will also belong to it. Why? Because from these two, A will be subset of C. Therefore we can say that this subset relation or proper inclusion is a relation defined on set of all sets, which is going to be partial order or poset. Got it? So this one is also poset, example of poset. Similarly, you can even think about this, right? And similarly, if on set of all real numbers, E is a divisor of, right? If A is a divisor of A, therefore it is reflexive. If A is a divisor of B, B cannot be a divisor of A unless A equal to B, therefore it is antisymmetric. If A is divisor of B, B is divisor of C, then A is divisor of C, therefore it is transitive. So this is also a poset. So posets are generally represented like this. What is that? The set of the elements, semicolon.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.